In the last unit we discussed inverses of linear functions. So since this unit we've been talking about quadratic functions, we'll talk inverse about those as well. So on this piece of graph paper here, I've got the equation y equals 5 minus x squared graphed, along with a nice t-chart over here on the left. Now notice this is indeed a function, but it is not a one-to-one function. It does not pass the horizontal line test, which means the inverse of this is not going to be a function. Now if you remember, all you do to find the inverse of a function is switch x's and y's. So I'm going to make a new t-chart, taking all of these input-output pairs that are in the original function and switch them. So -3, -4 becomes -4, -3. -2, 1 becomes 1, -2, and so on. And now I'll take all those points and plot them on my graph. I'm about halfway done already. There's 4, 1. Here's 1, 2. And -4, +3 is right there. And I'll connect all those points with a nice curve. And be sure to notice here that this inverse, the blue graph, is not a function. And that's why the original graph, the red graph, was not a one-to-one function, because its inverse is not a function. And I just put the line y equals x on my graph, and notice that the two graphs are reflections of one another through that line, and every inverse and every function and its inverse are reflections through that line. Now for the big question: what is the equation of this parabola going sideways? Well, in order to do that, we're going to need our original equation, y equals 5 minus x squared, and to find the equation of its inverse, we are going to switch the x's and the y's. So the y becomes an x, and the x becomes a y. And now we need to solve this equation for y. So first thing I'm going to do, I'll move the 5 to the other side. So that'll make x minus 5 equals -y squared. Let's get rid of that negative in front of the y squared by dividing everything by -1. So that'll make a +y squared is equal to -x plus 5, or 5 minus x if you prefer. And lastly, to get rid of the square from the y, we will take the square root on both sides. And when I do that on the right, the square and square root cancel out and give me plain old y equals the square root of 5 minus x. And one thing that we cannot forget here is I physically wrote in that square root sign, so it needs to be plus or minus the square root of 5 minus x. Now let's take and check this on our calculator to make sure this equation is going to give us that sideways parabola. Here's our original function, y equals 5 minus x squared. And now for the inverse, let's type in the square root of 5 minus x. But notice here I've only got half the parabola, and that's because I did not take into account that plus or minus radical 5 minus x squared, and that's why it's so important to have that plus or minus. So to get that minus part, I'm going to go down to y3 and do a negative square root of 5 minus x. And there comes the other half of the parabola. So our equation matches up with our graph.